similar kind of thing. One more minute. 5 minutes grace. I guess while I'm installing, my name is John Lewis. I'm with the Spectrum Scale development team. Gautam Shah and I, our responsibility is to lead the cloud and object team. I also do some other things, working on, for example, a network squad, work a lot of customer issues, and have been involved in, I guess, a lot of SBO shared nothing systems. So today we're going to talk about what we're doing in the cloud, and I want to do a little demo of some of the Amazon work. I just tested the deployment, made sure things worked okay. Always these live demos are a little tricky. I actually got a video on YouTube too, so there's always that backup. But anyways, I did test things, and right now we're in the process of deleting the stack on Amazon. So I was going to jump right into the start of the demo, but I'm going to put that on hold for a minute. Maybe we'll do a couple of slides first. Just want to really talk to you guys about what we're doing in the cloud team, maybe get some feedback. Feel free just to stop me at any point if you have questions or comments. So oh yeah, there's a standard disclaimer which says you can't sue me over anything. All right, so yeah, the overall flow, like I said, we'll move around just a little bit the live demo, but we'll talk about some of the things we're doing in the cloud team, the public cloud enablement that we're working on, details on the Spectrum Scale and Amazon solution, which I'm pretty excited about. Like I said, we'll do a little demo. We'll talk about where we are in terms of productizing that. And then we'll talk just a little bit about Spectrum Scale containers. Got some a lot of movement on that topic. So like I said, I'll move the demo just a little bit further back, and I'll just talk about what we're doing, what our objectives are, what our work items are within the cloud team. So one of the things that we're really focused on in IBM now is this hybrid cloud story. Multi-cloud is a term sometimes you'll hear now, which is really an effort in IBM to try to integrate with multiple public clouds so that you have different opportunities, different paths to move from on-prem or develop a hybrid solution. So we're focused on Amazon right now. And if you look at the the market data that's out there, Amazon is still in the lead. Azure is really gained some ground. That's what we're focusing on next. We actually have a prototype that we've done on Azure, and we're taking that further. We're starting to look at as well Google Cloud. So we've delivered a trial offering on September 13th on Amazon. We call it a quick start. So you can actually go out, and we'll look at that, to Amazon, and you can use Spectrum Scale for free for 90 days. We spent a lot of time trying to integrate, collaborate with Amazon in terms of developing a secure solution that's highly available. Once we got that initial solution out there, we've made a number of updates. One of the things that we've done is actually, even though the focus in working with Amazon has been on a highly available solution, I'll talk a little more about that, in order to give customers the opportunity to save money and maybe compromise a little bit to give you potentially better performance in the right path, right? If you don't have to replicate data across two availability zones, that offers you certain performance gains, and it also saves you money because Amazon is going to charge you for what they call cross-availability zone data movement charges. So that's one of the last things we developed in the previous update. The last update we did was focused on Spectrum Meltdown, as well as some other work that we've been doing in terms of trying to support expanding and contracting clusters. So like I said, we've delivered the Amazon offering. We're also looking at, we've always been working with, switching these around here, but software. We continue to do that. Our focus on software is really being trying to work with people that are trying to use Spectrum Scale on software, supporting them. And a lot of those teams have been IBM teams. In a similar manner, there's been a lot of focus on IBM on this ICP product. That that's really IBM's answer to customers who want to build their own private clouds and also offer integration with public clouds. So we, the Scale team, have been trying to make sure that we have the right support for particularly containerized workloads in an ICP environment. I'll talk a little more about our container support. Like I said, we have prototyped some work on Azure, and we're continuing to take that forward. And I guess the last item that I've got here is we continue to support OpenStack. I mean, that's another path to really, I mean, it's had much more success in the private cloud arena. I know there were players like Rackspace that seem to have really de-emphasized the public cloud usage of OpenStack. So we're kind of following in line. We have the technology out there in terms of our Cinder and Manila drivers. We're always willing to work with customers, and that's kind of a theme, right? We really want to see. I think we're a little out on the head, a little ahead in that, we're like the second IBM team that's really gone out to Amazon. We've had more of a stronger focus in public cloud, but we'd rather be out there a little ahead of people and kind of get feedback rather than lagging behind. So that's really the approach. So OpenStack, of course, is, it's tied to our object solution very much, right? Our object solution is built on Swift, and we continue to support that. That's something else our team does. And we're always focused on virtualized environments, which tend to show up in the cloud more. So we've done some work, for example, on the way that we document virtualized support. We've been looking at things like VMDK disk support as well. And containers are a really big portion of that. And then finally, we've been working on the automation of really some performance tooling to allow us to quickly assess the performance tunables that are on systems and apply sort of a holistic approach to the application of tunables. Those are the things we've been doing. All right, let me take a quick look over here and we'll see how we're doing on the, yep, we're all set here. Okay. So in terms of the Spectrum Scale on Amazon solution, so there's a quick start page. I mean, if you just Google Spectrum Scale on Amazon, you'll get to it pretty quick. But I'm on the landing page here, and I'll just talk a little bit about this diagram. Right? So what we do when we deploy on Amazon. So there are, within every region in Amazon, there are multiple availability zones. Availability zones, think of them like separate, fully contained rooms or buildings that have their own cooling, their own power subsystem. The idea is that in an almost disaster situation, we, in theory, should expect one availability zone to continue on even if we've lost another availability zone. And our deployment deploys across availability zones. So we set up Spectrum Scale servers in both of those zones, and we replicate the data across those zones. Our main focus is to make sure that we don't lose data. But we do have a way, like I said, now of deploying into a single availability zone that'll save you the cost of any time you have to replicate or move data across those AZs. We've been largely focused on the security and high availability of that solution. That was what we got out of the gate. And our team has more recently been looking at, all right, how do we really get the life cycle of this kind of solution down so that we can do things like expand and contract clusters. We have been talking with customers. We think that what they're going to want to do often is have a very fluid environment where they spin up a lot of servers and potentially, even some customers maybe at night want to spin all those servers down or bring their compute nodes down. And in the past, I think there's been some difficulty kind of being able to instantiate VMs, have them come and go in a very fluid manner. So we have been focusing on that. We're actually working with other teams because it's a common problem that we have, this deployment and lifecycle management. So we're trying to, in the install toolkit, build some common infrastructure there that we can leverage across multiple environments. That's not just the clouds, the Amazons, the Azures, the Googles, even other teams like the BD&A team. They've spent a lot of time investing in their Embari deployment. But if we could kind of, as much as possible, try to leverage the same infrastructure, that'll make it easier for us to debug and develop these solutions. So if I want to start something up on Amazon, I have a couple of choices. I can either deploy into a new VPC or an existing VPC. So if you already have infrastructure on Amazon, you can simply deploy into it. But in this example, I'm going to click on a new VPC. This first screen here is really the CloudFormation stack template. And all it's really doing here is it's pointing to a template that we have out on S3. This fills it in for you when you click on that link, but you're simply pointing to CloudFormation code, which is out there. It's available for anybody to look at. Everything that we provide there is under an Apache license, so you can go look at it. There's an open GitHub. We do have an AMI. You can look at that AMI as well, right? It's all public. So I'm going to walk through the details of what comes up when you click on this, right? We've tried to really simplify the number of options that are available to people. We're looking at maybe, offering more configuration options, but now we've erred on the side of trying to keep it simple. And we're trying to take feedback from people and figure out what are the things that we need to expand on. So I'll just quickly go through these, right? You have an option of the block size you want to use, the number of replicas for data. We always fix metadata at 2 replicas because we never want to lose the file system. Obviously, there are cases where if we actually lose data disks and we have single replication, you get an input-output error trying to access any data, but the underlying data should always be replicated so that we can still have the file system without having to bring in somebody to do surgery. So you can customize the mount point. You can customize the kind of EBS volumes that we're using for disks. EBS volumes, by the way, underneath the covers are replicated by Amazon. You can go look at their SLAs to see if they meet your needs, right? When we talk about replication, it's really replication on top of replication. So the underlying disk that we're writing to is replicated by Amazon, and you have to make choices in terms of what kind of disk you want to really use. It's all about price versus performance, right? What are your requirements? And Amazon does a pretty good job of documenting the SLAs around their disks, network support, and instance types. So then in terms of, right now we're looking at the NSD server configuration. By the way, this is a shared nothing environment in that Amazon doesn't let you attach a single disk to more than one server at a given point. There's no twin-tailed attachment. Everything is what we call shared nothing, in that no disk is shared by more than one instance. We do have some new code in 5.0, though, that now allows you to move around the attachment of NSD servers without having to unmount the file system. So that offers some new opportunities. So the number of disks per NSD server, the disk size, we've got the number of servers that we want to bring up. And if we're using two-way replication, that'll always be an even number because everything's going to be in pairs across the AZs. We have the instance type. I'm going to change that just to change something here. I'm going to prove that even on the smallest instance that Amazon gives you, this is one that is open to the free tier account. If you're in your first year, you have a certain number of T2 micro instances that you can use for free. Things, though, I want to just remind you, even if your EBS volumes and your EC2 instances are all in that free tier, you still have to think about things like data movement charges, and that's why this cross-availability zone charge is something I keep bringing up, because I don't want anybody to be surprised, right? You really have to read what are the rules that Amazon has for how they charge you. I'm going to change the compute instance as well to a T2 micro. And now under availability zones, I'm just going to pick the first 2 availability zones. I generally don't care which ones I have within a given region. In this case, we're deploying into Ohio. That was the Amazon region that we picked. It's just the AZs that generally really don't matter within a single region. All right, this allowed external access CIDR, that's simply a security mechanism where I can prevent other IPs from accessing the instances that I'm creating here. One thing I've done up front, I mean, there's a video that walks through all this, is I just simply create some Amazon or a Amazon SSH key. and I have that on my laptop already. So there's the SSH key that I need to get in, but it's an extra, let's say, level of security. You can also restrict the access that's allowed even if you have that key. So here I'm going to enter in that key pair that I created in advance, J. Lewis, Ohio. Bastion host, I could choose to use a different AMI. I'm just going to use the standard Amazon Linux. So that Bastion host, that's actually created entirely through Amazon templates. The idea is we're trying to partner with Amazon and make sure that we have a secure solution. We actually leave it to them to create that instance that acts like your firewall, your jump box into the cluster. So we're going to go with the default there. This bucket right here, we used to use that for SSH key handling. Now we really don't need it, but we sort of give you the option to create a bucket. You can use that to move data in and out of the cluster as well. There's other approaches that we're documenting in this guide that we have, but certainly you can use S3 in and out. And I think we have some opportunities in terms of functions that we deliver in scale, like TCT, for example, to kind of leverage S3 as a cheaper tier. You know, if you want to potentially take data that's cold and tier it out, it's still available within your file system, but you might want to save money moving it from EBS volumes out to S3. All right, your operator email, you can set up an email address that'll get notifications around your account, or basically the usage of the cluster. It'll tell you when it's up and running, and then you have to accept your license agreement. I'll say again, it's a free opportunity, a free trial. All right, on the next screen, I never really touch anything here. You can set up some alarms if you like. You can change the IAM role that you're using. It's really about monitoring. So then you can review all your options here. And you have to click, I acknowledge that this might actually cost money. And we're going to create the cluster. All right, so I kind of wanted to get that going. It's typically about, at this scale, maybe around 25 minutes or so to deploy. And you have your file system mounted. You can start using the cluster. We'll look at that sort of as we reach a few minutes before. So I'm going to jump back into the slides here while that's deploying. All right, we're talking about public and private, and I already told you guys we're just simply following the market data in terms of what we're focusing on first, right? Focusing on Amazon, Azure, and Google. All right, so I'll quickly say this. Why are we doing this, right? What are the drivers? Sometimes when I talk about cloud, I'm a little surprised at the diversity in terms of the responses that are out there, right? The people who are diehard. You know, people have come up to me and said, "What are you doing? Spectrum Scale in the cloud? It's a high-performance file system. Why are you trying to run this thing in the cloud?" And I say, well, partly because I think if it's not where we want it to be yet, and I think it can actually be a lot better than what most people, that's experienced when they start playing around. I mean, there's a lot of options. You can really do some high-performance things. Things are getting better. But really where things are heading are, I mean, we see increasingly that there are mandates for people to spend, or for companies to spend, a certain amount of their IT budget in the cloud, right? They're going to be forced, particularly government institutions are just going to be required to do this. We want to be out there working with you while we're all kind of figuring out how that play is going to, let's say, end up. So we have this pressure. We have, this CapEx, OpEx, let's say, requirement. We have people who just want to spin things up, right? We have the ability to do things quickly, to launch a cluster, just to try things out. We've actually had, for example, we've had ESS sales that were facilitated by customers trying our stuff out on Amazon, right? Rather than us having to build a system for them, get them up and running, we can just went into the quick start and away they go. So we've got, on-demand provisioning, rapid deployment, this agility, and of course, there's a price point, right? If you have a really bursty workload, you don't want to provision a system, an on-prem system that meets the capacity of that workload at its peak, right? Because maybe that system's sitting around idle if you can't keep it busy. But if you have time-sensitive workloads, there's a real case to be made, I think, for cloud bursting, right? Having some capacity in the cloud to meet a dynamic workload. All right, so we'll talk a little bit about Spectrum Scale on Amazon. I said some of this, I've already pointed you to the quick starts, a 90-day license. We follow best practices in terms of security and high availability. It's been a collaboration with Amazon. We can deploy in new VPCs or existing VPCs. And I talked a little bit about the Bastion host. And I've also said that we focus on simplicity. We're always open to working with customers if we're not presenting the right options now. You know, we've talked about different ideas of kind of having like an expert menu when we go into production, right? Other ways to somehow keep that balance between not overwhelming customers with the menu options, but giving people everything that they want. We use something called auto scaling on Amazon. So basically, if we lose a given instance, let's say a physical machine failure occurs, what will happen is Amazon detects that, and the way that we basically use CloudFormation, we set up this auto scaling, and there's really two things that are going on here, but we'll keep it simple. If we lose a physical machine, in theory, we've still got the disk that backs that, and underneath the covers, Amazon will just spin up a new instance that looks exactly like the machine that just failed. So what'll happen is it kind of looks like a machine rebooting from underneath you, rather than just a hard physical server failure. I've already mentioned the two availability zones, and I've talked about the configuration choices. And I showed you guys the little diagram here. I want to point out that we actually create a private and a public subnet, and we have NAT gateways and a Bastion host. Typically, there's an option for deploying into more than one subnet. For now, we're deploying into one by default.
Oh, is that a stretch cluster? In terms of spectrum scale, what is it?
So the definition of stretch cluster it's not really well defined. It's somewhat overloaded, but yeah, it does meet the definition of one definition of stretch cluster, right? And the idea is you have two separate zones, and everything is replicated across those zones.
So what about the ping latency? What about the quorum?
Well, the quorum, we're actually working on a second update. I'll say our main focus right now is to make sure we don't lose data.
Yeah. So
what we have prototyped and worked with other customers is we set a third availability zone up. We've got one node sitting there, and think of it like a tiebreaker. So that's it. That's the answer to quorum. That's what that's our plan to deliver. For now, we were simply, like I said, less concerned with keeping the cluster up, more concerned with making sure we never lose data. So even if you wiped out an entire availability zone, there's a 50-50 chance that your cluster would go down, right? Because you might lose quorum until we implement in our production version of the templates this tiebreaker. In terms of the ping latency, it's not so bad, but that's one reason that we offered the option of deploying into a single AZ, right? So if that latency, if the performance cost of moving the data, and even the bandwidth implications of writing, I mean, it's about latency and bandwidth. If writing that second copy into another AZ, if that's a problem for customers, you can accept the SLAs that EBS volumes give you. I think that deploying in a single AZ is a good approach. All right, so in terms of what we've done, just quickly the updates. Like I said, we deployed in September our first version. We released an update in November, which was cleaned up a few things in the AMI. We added this what I really refer to as the fixing of metadata, which we basically decoupled data and metadata replication from the options that we presented in the CloudFormation. We changed the root volume. I'll go quickly through this, right? February is where we made those changes I referred to in terms of operating or offering a single availability zone. We did some code refactoring to improve scaling. Some of that was at Amazon's, let's say, collaboration. And then the most recent update, we have Spectrum Meltdown vulnerability fixes. And we actually haven't documented these because we're trying to work with a couple of customers, but we have that first round of new code where we add expansion and contraction support. The next thing we're working on is we're trying to focus on a GA offering. So we want to make this fully supported outside of the quick start. What we really want to do is release, remember my lawyer slide, but our intent is to release something on the Amazon marketplace. And what we think there, is something very appealing about an hourly method of charging for scale, right? A lot of people don't know this, but you actually can buy scale by the month. That's sort of a lesser known feature, but most people are locked into a different either capacity or socket-based long-term license. All right, so in terms of data flows on Amazon, I'll just try to be brief on this, but what we're trying to show on this chart is that we're looking at different ways to move data in and out of clusters. One thing that we think in the Spectrum Scale portfolio is compelling in this environment is AFM. And we obviously, as I mentioned, so I'm thinking of it on the left, right? We've got this on-prem cluster here. Maybe you're doing some on-demand, you might be doing cloud bursting, you might be doing, one-time ingest. You're sort of setting up your environment from an existing on-prem cluster. You could do that through AFM. You could do it through, rsync. We've actually been talking with the Spare. I'm interested if anybody has thoughts on that. We're sort of looking at a lot of different approaches, but the idea is once it's in Amazon, you could potentially tier it out to S3 if you want to maybe do some space savings. You can do snapshotting of the NSD volumes. You can be sharing with other applications on Amazon. We're also looking at things. We don't support this. We have a lot of restrictions right now, but a lot of those restrictions are, in fact, not really necessary yet at this point because we've done the testing needed to kind of make those things work, but we're trying to work with some customers on a smaller scale before we kind of open the floodgates and make everything officially out there. And then data export, looking at ingest and export, right? You could push it back via AFM or any number of ways if you're doing cloud bursting. You could be doing NSD snapshots, saving your data S3, or you could just be copying things directly. Like I said, I keep mentioning this, but I really think we need to pursue this TCT approach a little more. That's something that I think offers a real potential to save money when you look at the cost of S3 over EBS. Okay, we've got a lot of publications. These slides will be out there, so I won't go through them. Like I said, there's a video I've got on YouTube. There's a lot of stuff that the cloud team has put out there. So I'll just ask briefly here some questions here. I don't want to slow it down too much, but anybody here interested in running on Amazon? Okay, great. I got to ask this because my OM always asks me, anybody would actually pay out of those people? I mean, it's out there for free now, right? But obviously, at some point, we want to make some money on this.
Yes.
Okay,
not my money, though.
Fair enough. What about Azure? Anybody interested in running on Azure? Okay, great. I want to ask the pay part. I think that's in play. All right. Any other public cloud offerings that people are interested in? Google. Okay. Those are the three we're looking at. We do not have our sights on anybody else. So if there is interest, I'd like to hear it.
I've heard about Alibaba, but it's not really customer.
All right. I'm going to talk a little bit about container support. I guess.
John, can I wind back to
sure.
To performance? Have you explored the performance characteristics in any kind of depth?
Yeah, we're working on some more documentation, but to me, it's mostly about the network, right? Really, that is what dictates performance. Okay. So you really have to look at the SLAs and try to think about that. Something I've been working on is what if you need, let's say, think of something like a large block I/O streaming benchmark. What if you need to meet a certain bandwidth requirement, deliver it to your clients? What's the best way to do it? Right? Because you can you have a choice in terms of the instance types, the volumes, the number of volumes per server. You've got really two network considerations. So on Amazon, you've got the bandwidth back from any given server to its EBS volumes, and that's a separate network bandwidth depending, on the type of instance and whether it's EBS optimized. And then you have the bandwidth from all the servers. It's really everything else but EBS, and that's the key thing is to make sure that your servers and your clients have the right bandwidth. And I mean, Amazon, they have these high network instance bandwidth that they really only give you about 100 megabytes a second. Then you can get up into, you've got 5 gigabit, 10 gigabit service. So there's a lot of options out there. For the most part, it really is the network that limits your bandwidth. Obviously, latency is a consideration for a lot of workloads. And then the real concerns become around how do you deploy this thing. So we don't right now offer in the quick start this concept of placement group launches, but that's something that we are working on for our production offerings. So if you co-locate as much as possible your servers, that largely addresses, or that's the best way of addressing latency concerns.
I think it's bandwidth as well, because you've got the south network parts get constrained as well.
That helps as well, yes. I mean, there's still potential for the right kind of traffic patterns to see congestion within the network. That can be somewhat mitigated by the way that you place those servers. So placement groups is the way to go.
And how big have you pushed it in terms of gigabit cluster size?
So 64 is really where we're trying to get Amazon to do something larger. Our performance testing has been, for the most part, smaller systems. Right now, we're trying to do some work to do some larger scale performance tests.
Right. 64 clients or 64 entities then?
64, a total size, 64 instances.
Do you consider mixing up the computation and NSD functions then? So if you're building your first cluster and you go for about 64, I guess you could run the workload on the GPFS service, right? Which would give you you would avoid the north-south problem between your clients and your NFTs at that point.
Yes, there are. So this is a whole discussion we should maybe have in a break or something. But I've done a lot of work on these converged systems, FPO systems,
right.
And there are real advantages to separating the client-server function. I'll say that. I know that there are two sides to the coin, and if you were to look at things, like I said, you've got different bandwidth back to your EBS volume. So potentially, if you had the ability to affinitize your data well, there are some real performance advantages. And I'm very sensitive to that. I get that. It's just, yeah, we should talk a little more about that. There are real reasons for separating the roles, but it's a tough.
Yeah.
John, can I ask a question as well then?
Sure.
When you compare what you'd be doing on Amazon with maybe what you could do on Google or Azure, are there any technical differences between the way the three are done, which makes spectrum scale a good fit in one or a bad fit in another?
Yes. But because we're not as far along, and there's still some debate on the Google and Azure, let's say, work that we're doing, I want to hold off on that. But believe me, that I think has to be part of what we focus on as we try to. We really have something out there on Amazon. I'm telling you, we are looking at Google and Azure. I want to let that work continue a little more before I start talking about the trade-offs across those different public clouds.
And for many customers, it's the incentives coming from Microsoft or otherwise that leads them to one choice or the other rather than technical.
It's a very good point, and we've heard this, that often it's really it's a company-wide decision. We've talked to people. They say, well, our overlords say we have to go to Azure, and they don't have a choice about it. Yeah, I'm really biting my tongue here. All right, so on the container support, I mean, this is just, yes, containers, they're going somewhere. I think they're going to catch on, right? So, yeah, there's a lot of reasons why. I'll briefly go over some of the points, right? Containers, I mean, they're portable, right? You wrap up all your dependencies in a single image. You don't have to worry about, as you move from one system to another, do I have the right version of Perl? What about the Python code? What about my libraries? Everything is wrapped up, nicely contained. You've got the potential, particularly in a scale environment, for some really cool things in terms of multi-tenancy, the ability to bind mount a portion of the file system into a container and to give the user root, right? You can use user ID mapping through the namespace function, where you can basically give them root in the container, but they have their regular ID accessing a scale file system. A lot of potential there for multi-tenancy that we really haven't had until now, I would argue. Data management, the ability to, I always think of even containers kind of like, they're almost like little mini GitHubs, right? In that you have this layering, sort of as you build a Docker container, you're building sort of in layers and it's some change control there. A great way of just managing your data. Although you never really want to, in my opinion, you don't want to use the data directly in the container image for performance reasons, and that's where scale comes into play, right? You want to mount some external volume into the container that becomes now your global namespace, and that's how you share across containers, right? You know, we have the ability, if we lose a single container, simply, you know, think of like Kubernetes, right? If the pod gets launched somewhere else, well, the file system's everywhere, right? It's a real advantage of a clustered file system. So I think we have a definite use case there. High performance, right? With the bind mounts in particular, you don't really lose any performance, right? I mean, we can use NFS. We have used it. We've actually worked with, you know, somebody in IBM was running a file service to Kubernetes. They were NFS mounting GPFS file systems. It works. When I think of the advantages, you know, I think of minimal dependencies on the clients, right? You don't have to worry about the GPFS code. You're just NFS mounting, and you have all the wonders of GPFS on the back end in terms of snapshotting, you know, our DR function, all of the performance that is still important even before you export the file system. So a lot of advantages there. Containers, you know, compared to VMs, they're fast, they're lightweight, right? You don't have to wrap all those kernel dependencies and you just bring in the application stack. You've got, of course, through C groups, you've got the resource utilization controls. You know, I mean, they're open source and they're global repositories, right? You go out to Docker, you just got tons of containers that are out there. We're seeing often that, you know, an example might be in genomics, right? Where there's kind of a requirement to use these existing pre-built containers so you have a good starting point. So people are running their experiments from a common framework. All right, so I'll go through quickly the high-level strategy for containers, and then maybe we'll circle back to the quick start here. So, like I said, we've looked at Kubernetes. We've also done work with Docker Swarm. We've used GPFS and NFS exports. We know they work. We've been engaged. My team was engaged last year in an open source project called Ubiquity. We pulled those people off for a while, but we're back participating in that project. There are other IBM teams that are working on it. So the latest code that's out there there are issues with Spectrum Scale. There are earlier versions that work. We're back now working on that code, and we intend to deliver scale support. We as a development team plan on supporting it through GitHub issues. It's not going to be through the PMR process. Development will be supporting that directly through GitHub. You know, what else can I say? So, you know, at a high level, where do you need Ubiquity, right? So, I mean, in a Kubernetes environment, we have got some customers that are using HostPath. HostPath driver will work for you, provided you have all your directories created up front, they have the right permissions. If you have a more dynamic environment in mind, things where containers maybe need to create their own storage, some, you know, concept of dynamic provisioning, you want a container to launch, a file set to get created for that container on the fly, that's where Ubiquity comes into play. It's also better integration in terms of Docker Swarm as well. There are some ways that we're looking at other approaches with Swarm, but I would say right now, Docker Swarm is your approach.
Is Ubiquity calling your REST API to create those classes?
Yes, it is. Exactly. That's the latest code. We're actually trying to remove, we've got a couple of backdoors where we're using SSH and that I don't, quite frankly, I'm not too crazy about. I mean, but all of the file set creation is done through REST APIs. In Ubiquity, there's a concept too of this lightweight volume. That's not a file set, that's just a directory. And I'm really trying to figure out, do customers need that? I'd rather see everything done through REST APIs. All right, so we're also focusing on, as I said, on IBM Cloud Private. We've been working, integrating scale into that environment. We've been doing some talks. You know, we're interested, if anybody's looking at ICP, like to hear what you're running, make sure we have a good story for it. Like I said, we're always interested in feedback. So I think I'm going to skip through this, right? Basic sort of 101 of containers, right? You can mount a given, you can bind mount any path you want into the container. So that you could do things like you could have different projects, which simply, you know, depending upon the user that's running, it always looks like /GPFS. It might be a different source map. I got something here. I tried to sum that up just a minute ago in terms of a little decision tree for when you need Ubiquity, because I know we're a little short on time. I got a pointer here to the Ubiquity GitHub. Like I said, we're supporting that in development. Official wording is best effort GitHub issue. Reach out to me if you have questions on that. Okay, so I'll ask anybody here interested in containers. This number of hands goes up every time. Good to see that. Yeah, what about Kubernetes? Let me go the easier way. All right, what about Docker Swarm? We're seeing a shift, right, more? Okay, so that helps. Yeah, IBM, our strategic platform is Kubernetes, right? But we started out with more even split. We are continuing to support Swarm. We've even got, 1 or 2 customers that are interested in these. All right, so I'm going to circle back to the live demo here and show. All right, so here you can see we deployed in, so I look at the events. So 9:40, everything completed. We started this at about 9:28. Okay, so let's see if it actually works.
10 minutes, that's substantially less than the 20 to 25 that you said. Is that recent improvements?
We have done some scaling improvements. It's pretty darn good, actually. I want to make sure I didn't miss anything, but that's pretty good.
Is it using 5.0 now, John?
The latest version is 5.0. Okay. All right, so we'll click on, go into the EC2 dashboard here. And yeah, you can see that's the terminated ones or the cluster I brought up before here. I'll look at the Bastion host, right? I click on that. I get its public IP. And you have to go in. What I've done is I've set up SSH agent forwarding. So I'm going to simply, I point to the key that I created in advance. I give the IP address. And then from here, now I'm in the Bastion host. And because I set up agent forwarding, I can jump into, let's say we'll pick any one of these here. So we've got a running server here. Unselect that, and I'll grab its IP address. I'll just say, type. Okay, and we're in. So uptime. 15 minutes. So the reason that it says it's been up longer than that 9:40 time, there we're up and running, is because that 9:40 is when we completely finished all the cloud formation work. So that meant that the file system was completely mounted, right? So the instance has been up longer because we've been running spectrum scale commands and building that cluster. But yeah, I'm feeling a little, 12 minutes, that's pretty good. Did I miss something here? So I don't know, I'm gonna check that again. To be honest, I'm gonna say, I haven't seen it deploy that quickly, but it does seem to be up.
The US are all in bed, right? So.
That's it, there you go. Yeah, the file system's mounted, yeah, GPFS FS1. Sorry, you wanna see MMLS MSD? Oh, of course. I got to do that as sudo. There you go. All right. I got about, I'm supposed to stop this 5 minutes for. So I mean, I can jump back to slides, but I'll just throw it up for questions. Is there anything anything at all you guys want to hear about in terms of cloud, containers, virtualization support? You know, I mean, another topic I haven't brought up in a while is sort of, you know, our VMware story, right? To me, I thought one of our let's say gating issues in terms of our software support, and I think also a lot of other customers have brought this up, is we don't support VMDK disks right now, right? We only support RDM devices. I, you know, trace through why we don't support them. We have a plan for actually drop some code to try to address the issue that prevented us from supporting these VMDK disks, and I think we're pretty close. So yeah, I just want to throw it up. Anybody have questions? All topics are on the table.
Can we choose the version when we deploy?
Sorry? The version of the software? Right now you can't on the quick start, but that's a really good question. So one of the things that we've been trying to figure out in terms of our production strategy is how much freedom we give customers, right? There's one thing that a lot of people, the idea of a common image resonates with a lot of people, particularly the guys that are worried about support. They really like the idea of us offering something, testing the heck out of it. I think in Amazon, one of the things I like too is that the number of combinations that we have to worry about is greatly simplified, right? We've got everything, it's open season, you know, on our on-prem deployments. With Amazon, there's only so many types of disks and instances that you can work with. Obviously, you have the same, in theory, you have the same number of choices in terms of OSs and versions of scale. But if we can minimize some of that, it makes it easier to support. What we're thinking now is for our production flow, we have an NSD server image that we want you to keep the same. But we allow you to deploy an AMI of your own choice. We give you some guidelines on how to build that AMI, but in theory, we might support all of the, at least all of the OSs we support. But you tell me, are you more concerned with the version of scale in terms of compatibility with your on-prem systems, or the things you want to go to 5.0? What is your thinking on the whole version issue? DevOps. Okay. And does it matter? Let's say I told you we were only going to, right now it's Red Hat, right? We have Red Hat 7.4, right? We have our Spectre Meltdown fixes out there. We've got 5.0. Is that okay for you, or is there, yeah? All right, good question. That's something, you know, and if anybody has comments on the question I raised, right? Is that a good strategy? Sort of locking down the NSD servers, trying to keep people using a single image, but giving you the freedom to pick your own client choices, or having some freedom there. Is that a good compromise? Anybody object to that? Anybody want to throw fruit up here?
Well, John, really, are you trying to differentiate between how to get started easily to make the whole toolkit easy and approachable for everybody? And if you've got power users, they're not going to go this way anyway. They're going to do it all manually, script it.
I'm not sure about that.
Yeah.
I would really, so I think there's something really nice to deploying this thing like I did, you know,
Yeah.
rather than you bringing your own RPMs, FTPing them up there, launching all the instances. If we could give you a little something, that's where I think there might be a nice compromise, if we can do everything through a user-defined AMI. You just plug in your AMI ID, and we've actually tested this with another customer, and it worked great. So the key is we have to make sure that the way you build that AMI follows our guidelines so that it fits with all the rest of our back-end scripts. But what we're doing now is exactly what you said, right? We're trying to make it super easy for people to use with a quick start, but I would rather that people didn't have to roll their own in the long run. If there's some way we can help them.
There's a lot of performance and optimization and power usage that you have to put into the Amazon end of it now, right? So you saw your instance drop down choices. Amazon have 100 different instances type you can get. And so there's so far you have to push your power envelope before you even think about, you know, changing to Ubuntu rather than Red Hat, right? Or whatever you want to do. And it's not the ecosystem isn't really anymore about building a big custom thing in the cloud environment. It's much more about rapidly getting to a point that you can start producing whatever it is you're producing.
Yeah,
I agree.
So when you add in the glue, if you like, to connect that to something on premise, the AFM and the rest, would you want to do that in your GUI, or do you want to script it like you guys might do?
Yeah, I think that's another question, right? How do we sort of manage the, let's say, the deployment of features like AFM? How do you integrate that into your cluster? I think that's another discussion. So far, we don't have that in the GUI. That may be something that we provide some either scripting, samples.
Because every on-prem site's going to be different.
Well, exactly. So it's very hard.
Yeah. I agree. Is there a question?
So, I think the auto-scaling is absolutely key benefit, definitely. I think one of the challenges is still thinking about it from your application perspective. So you've still got to get your application images out there. They've got to have the GPS clients on them, and you've got to keep those maintained in lockstep somehow. Well, I think that part's non-trivial there, and I think could like certainly a challenge, certainly to automation.
That's why, at a minimum, I think we need this option of deploying your own image because, let's say you're running something like SaaS, right? Maybe you want to configure SaaS, whatever your software is. You don't want to always have to put that on top of a GPFS image. So, yes, I think where it gets really harder too is if we're going to do this hourly thing, and we certainly intend to, right? Now, yeah, how do we make sure that? Because if you don't have a scale license and you're deploying hourly on Amazon, presumably you don't have the RPMs. So how do we deal with that, right? So far, my best idea, the best approach is we start you off with the images that we launch, but we try to give you a little. When I say the images we launch, what you deploy from the marketplace has scale on it. Those instances come up with scale all configured, and then maybe we try to provide some integration with whatever else you need to put on. Yeah, I think that one gets a little harder in the marketplace.
The sort of way that it could be used, can it integrate with Glacier? Sort of be really cheap storage. Is that sort of the way that this is intended to be used, or is that something that is breaks it horribly or anything? Because the idea of having your on-site system and being able to tear off all the stuff and go and shove it onto really cheap storage is quite compelling one for me.
Yeah, I completely agree. So in terms of Glacier, I mean, right now it's manual, right? So you can push things out to Glacier. Certainly, what I would like to see us work on is this tiering through our TCT product, where you can at least push things out to S3, which is vastly cheaper, not vastly, but it's certainly cheaper than EBS. So absolutely, I really think that that's an important piece of what we need to deliver. Glacier is just another cheaper sort of tier. I almost think of it like another, the cheapest object storage tier they have.
Just when you go for recall, sort of GPS also knows nothing about that. So basically, at that point, all you're doing is you've got two silos of storage and just manually moving stuff. It'd be nice if that process could be more seamless and managed on the GPS.
That's really where TCT comes into play. Yes.
So that's future plans.
Future plans for us to integrate with TCT, yes. But anybody who really comes and pushes us, Chris is smiling back there. We can have our arms twisted, right? We want to work with customers and do some kind of POCs, right? If we do things on a smaller scale for people that are really interested in something, that helps us flesh the ideas out, make sure there's a real good use case. We're really trying not to, I feel at times, we got a long restrictions list. We're trying not to just throw everything out there and say, to see if it works, right? We're really trying to pick things that we know work and then see what customers come back to us, what else they want to do, try to work with them directly, really make sure that this is all the things that we spend time developing. We want to make sure there's a real customer interest in those things. All right, I am at time. Any last minute questions?
I was going to ask, would it be possible for you to support the current supported versions? So at the moment that's 4.2.3 and 5. In order for us to match what we have for testing purposes? It's possible. We started with 4.2.3, so we know it works. That's the discussion earlier when I was saying, we should talk a little more about that and see whether the idea of having a fixed server breaks that approach. Right? I mean, we do have N-1 support, so I think a lot of things don't have to be at the exact same level, but I think we're flexible on that. I think the future is to say, I want to replicate my environment, test environment, No, I get that. That's important. DevOps, yeah.
If you give support to being able to adjust the output of the store. We find that with you.
Sorry, the,
Yeah,
yeah, we're working.
Yeah, I'm sure.
Two sessions at the same. They've got two sessions exactly at the same time. Yeah, your two are exactly the same time. I've got it there.
That's an interesting idea. We haven't done that. We are using the toolkit, and we're actually working on this. We have a guy on the
Yes,
toolkit
so you're
team.
in board.
Hey, Chris.
Sorry, I missed the very beginning. I was stuck on a train.
That's okay.
You made it here.
It was only for 30 hours.
We've exchanged a few notes around
Thinking on a plane to Rome. It was like JFK,
Yeah.
Finding out what's going to get out of there tonight.
I'm actually responsible for spectrum scale, ESS, as well as color
Putting on a
storage.
bus, take you to Newark. So if I Newark, I'll take you somewhere else.
I tend to see minimum, so
Take you to stops.
I think it would be good to hear what progress
I just dealt with
so stable and we are seeing
And my hand has an additional reason. Very strongly recommended.
Coach DR on
Restore
Restore
This is the AFM one in here.
Yep.
Do you want the file system audit
Yes.
or rest taking islands and the two rooms at the back?
You go ahead, that's the main
I got it.
Okay.
Now, time we talk a little later.
Yeah, definitely.
Good.
Right.
No,
I didn't see.
I had to go back and work on the kid. And
I
I wrote a
I
call
worked,
last night.
I was sent till 8, but I worked till 2 this morning, because I called at midnight, Singapore.
What is the time difference? What is the time difference with Singapore? Is it 6 hours?
6 hours, but I had to do it at midnight because we had US guys.
Oh, I see.
Yeah, so then it was 7 o'clock in the morning, so then midnight for me, and the US guys, it was 3.
Yeah.
So, that's very unfortunate. Just Europe and Asia is okay.
Yes, yes, yes.
I was having to supply Power 9 laptops yet. I can just wait for that day when I go and kick out their Power 9 laptops and everybody over and have to do the Power 9 one. I don't like. But then it's got to work on that.
We have a few somewhere, which is linked to very large. The largest one actually is for storage units. By the region. So we have PFC and two features that we have defined one do not seem too good to be true. So one is we have synchronous or asynchronous communication. And applying to test that we perform asynchronous communication. You can actually fail over if one or two sides. And that failover doesn't work. And we have issues you synchronous and like cost to care that it is hardware agnostic. By the time they do provide the US.
Yeah, they do provide.
Right, and their OS is back. And when we try and this is the hardware choices. There's nothing. Well, the driver should come with because converter is running late. This is our first live POC. So Julian is gonna just coming. It's being escalated for them to shine right now. We haven't found seven. I don't really.
I'm wondering how they want to follow up.
I believe it's the verification.
Yeah, because agents normally do right. So why do they want to follow over? I'm wondering. Because normally it's just you have a geographically, very far away. That you just switching things at a thing, right?
I
Are
don't
they
like
writing the two maybe?
I asked the question on how they want to receive.
But it could be maybe they're actually doing async replication to two sites. And then everyone says, well, no,
Yeah, I think it's basic approach across two sides.
oh, okay.
If one side was down, one of them will
To
continue.
me, yeah, on the other side.
I agree with you.
Yeah, correct. And that's what. That's pretty good.
And you know, that was to do the Christmas. I cover those issues because there's no real. Three of which.
Yesterday, talk tools.
And they're right.
Is it 2,000 volts? 3 or 4 kilometers.
So are you attending the business technical institute?
No, but
Oh, Benoit.
I'm going to, but there's a event in Lilligan is a pond but there's a client
Oh,
so I'm going there to talk about.
oh, okay, perfect. Yeah, I'm the technical university. So I'm presenting hot with hot. So I've been doing that now 2 times already.
Yeah.
Practicing skills of
So they built
The number of followers, opportunities. What I can dedicate to my course. You know, choose your skill experts and your friends.
I don't know. Yeah. They do it.
So it's our scheme experts covering the customer stuff as well.
At least the
I have some good.
No.
It's
identified as they're not here.
Thanks.
Yes. No.
If you send it to me, the statistics and for those engagements.
Collecting it.
Sorry about that. Okay.
Yeah, so I am Venkat, and I work for AFM development in the spectrum scale. So I'll have a brief history of why the AFM is created. So it started as a research project in Alberta, and became a full product. So today, right, the major problems, right, the network, right, dealing with the network latency and the data that we have, and we want to share across the clusters. And the major problem with that is like we want to have a data locality and also want to have a efficient caching. And so the AFM actually it addresses it in a different ways. So one of them is like you have a local caching, provides many more primitives, different types of file set modes to support the caching. And so one of them is like, which includes the caching, migration, and DR. That's where the AFM is positioned. So mostly the major motivation behind AFM is to actually address the network latencies, right? And to cache the data locally so that you don't ever have to go to the network like NFS. It should not be chatty like NFS protocol, but still you provide the local. And so based on that, like the AFM have the caching capabilities. There are different types of modes that AFM supports for both caching actually and also migration and DR. So there are different types of file set modes that AFM supports. And typically, the AFM is part of a spectrum scale. It's not a layer, or it's not a modular kind of a thing within the spectrum scale. It's a core spectrum scale. You can't even, there is no modular thing. You cannot take out AFM just like it's. So it actually kinds of hacks. It traps the VFS cards to record the changes. Unlike traditional, unlike a regular backup replication things where the tools have to scan entire the file system to find out the data. It's only for the cluster file systems, but if you have a single node file system, usually you could use I-notify events to keep track of the changes and do the replication. But AFM, it works at a cluster level, and it keeps track of the VFS calls and stores the operations at the gateway node. And typically, the application modifies the data, and for each the modification, right, that happens at the application node, it sends an RPC to the gateway node to record the change in memory to send it for the later replication. Right? And of course, it comes up with its performance cost, right? Because you're sending a message to the gateway node in application file. And I will talk the performance later, but there is a performance thing because you're not using a fast path for the application for data writes and reads. It has to go to the other side, gateway node, and if it is a synchronous messages within the caching, and they have to go to the home cluster to read the data into the cache. So this like AFM, right? So to keep track of the changes in memory, and it requires. It also comes up with some memory requirements at the gateway node, based upon, and also have some computing resources at gateway node. I will talk about them later. So there are different types of modes that AFM supports, right? Read-only, local updates, single writer, and independent writer mode. So the read-only caches, so people usually look at the data from the home clusters, see run some kind of analytics on it. Anything like it's just read-only. You cannot modify the data and send it back. It's read-only. And the local updates mode typically you want to pull the changes from the home cluster, but you don't want to replicate the changes back to the home cluster. Say if you want to do DR testing, you can point to the existing DR cluster, create a local updates mode, pull the data, modify the data. You can see do the kind of DR thing, discard the data. It's not replicated back to the home cluster. And single writer, it's kind of a DR. It provides a backup and also kind of a DR solution, but it's not. It doesn't provide itself. Right? It does not contain the failover and the failback capabilities, unlike AFM DR. But it provides a true backup and kind of a DR solution. But you can fail over to the AFM home site, but it's not. There is no real failback. You have a cache that comes back. So the independent writer, yeah, I mean everyone knows about it. We have problems with it because of this performance thing, and it have revalidation problems. So we are trying to address and how to solve them. I will explain in the later slides. So most of the data updates are asynchronous. I mean, almost all, except there are few operations where, like, say if you try to write a file in a caching mode, if the file data is not existing in the cache, so the first AFM has to read the file from the home to the cache before allowing the updates to the file. It reads the full file. There is no partial file caching from the right. And so that means it's a synchronous in a sense until the file is cached in the log fully, and once the file is fully cached, it's an all asynchronous thing, whatever the updates you make. So AFM supports two types of protocols. I mean, at least today. One is the NFS, and it is remote cluster mode (NSD). And using them, you can replicate. So usually the NSD is used for within the LAN or high. I mean, you have a good bandwidth and low latency network. NSD protocol is preferred because you get a good performance, because the NFS is limited by the. I mean, it has its own limitations. It's like it can have maximum 1 MB buffer for reads and writes. NFS has that limitation. And so the AFM works at file level, that is the independent file set level. So it does work at file system level, and which we are trying to come up with, but not now. It's not committed yet. It's the intended thing. So that's about AFM caching. So AFM has also have DR solution. Right? It has the goals, like as I explained here. Want to asynchronously replicate from the primary site to the secondary site, and in case of primary site failure, move the applications to the secondary site, and there can be maybe the primary site is never coming back, and you want to build the primary site again from the scratch. That is supported, and also you can make the existing secondary as a primary, and you can do the role reversal automatically, like whenever the failover happens. So there are multiple options. Either you can create a new primary, you can create a new secondary cluster, you can do the role reversals between them. Right? So it's a true DR solution with a continuous replication. Right? So unlike traditional. I mean, without I-notify, at least on the cluster file systems, like, because the AFM keeps track of the changes in memory. I mean, even if you change a 1 byte in 1 terabyte file, it exactly writes 1 byte back to the DR site, because it knows what changed. Right? So it's very efficient. it's continuous replication. It's a true DR, right? I mean, it's by default AFM DR or the AFM caching are in single rate or more. It tries to replicate the data within 15 seconds. That's an asynchronous delay that you set. And also it supports appeal snapshots on the kind of where in a DR term it's called RPO, recovery point objective. That is the by default it is 15 minutes. So it tries to create a snapshot within every 15 minutes. I mean, by default to make sure that both primary and secondary are consistent with respect to that snapshot. But AFM DR itself do not require RPO snapshots for the replication because it is a continuous. I mean, it's not depending on any snapshot for the replication. It's not reading from the snapshot to replicate. It's a continuous replication. And you need RPO snapshots only for the crash consistency, which is called right ordering, like your databases, where they need a right ordering. So the right ordering is preserved within the snapshots. Right? Without RPO snapshots, you will get a eventual consistency. I mean, like if you are doing kind of unstructured data, you don't need a snapshot because you can file over to the live file system. For the applications which requires a crash consistency, they need to restore from the snapshot after failover and get to a consistency point.
And will you talk about the required performance, latency, bandwidth in order to be able to run AFMDR effectively? Because I think there are some performance consideration between the two sides, right?
Yeah, I mean, so it all depends upon the rate of changes. Right? I mean, if AFM can get to the pipe, I mean, if you're using NFS, I mean, you can see it in, if AFM can saturate the pipe and fill it. I mean, it depends on the workload. Right? So you need to tune the AFM accordingly to utilize the pipe. So this is like how the disaster recovery, right? I mean, not be talking much on it, but just picture like the primary is pushing the updates asynchronously, and once the failover happens, I mean disaster happens, you can failover the applications to the secondary side, and you can. So the most of the data will be there, and if you want a consistency, you can restore from the RPO snapshot. You can see the failover failback happens at the file set granularity. For each file set after the failure, you need to manually failover the file. It's not the protocol information and all not replicated. It's only the files. It's only file data and metadata. So there's like the migration, right? I'm using AFM. So it supports two protocols. I mean, if you have a GPFS other side, you can use the remote cluster mode to get the data. Otherwise, you can use the NFS. So like AFM migration supports, it's really not a real downtime. I mean, you just need to switch the applications back by creating a caches pointing to the old system, so that the application can read the data on demand. I mean, so whenever the application requests the data, AFM sends a request to the old system, either using NFS or NSD protocol. That means you really don't need a downtime if you're using AFM migration. So it supports the different types of modes for the migration. If you are using a single writer, you can still write back to the old system until you cut off the old system, basically. And if you use an independent writer, I mean, we would not recommend the independent writer because it has a performance overhead. But if you have a true requirement to modify the data at the both sites and old and new files, new sites, then go for independent writer. But it's not recommended. And the local updates is basically you can keep migrating the data from the old system, but when you update the new system, you don't want the replication back to the old system. Say, for example, you're running out of the space already at the old system, and you buy a new scale and want to migrate the data, and you have enough storage, but you don't want to make the changes go back to the old system. You already have no space there. that's the local updates you can use and do the migration. Right? So it supports HSM. I mean, you can AFM migration. It doesn't result in any recalls. That means so you could migrate. You can give the list of files saying that you do the DMAP stuff. I mean, it will get the inodes with extended attributes with DMAP ES, and it will not result in the recall. So you could point the new system to the HSM server. It will do the it can recall from that. Right? So that, I mean, unlike if you use any other thing, like even any other technology, like either RSync, any other, they result in recall. But AFM recognizes that the files are already migrated, and it will not. It will just pull the stuff files, not data.
When you say migrated, does that cover Spectrum Archive migration to date,
Yeah.
or transparent cloud terrain migration to cloud?
Yeah, everything.
Everything.
Everything. It's also, I mean, it knows that when the files are migrated, there are extended attributes added to the inodes, right? The DMAP attributes. It knows that using them, the files are stuff files. So it will just use. It will not result in recall. So it's like file level granularity. So you know exactly, you can do kind of a progressive migration. You know, want to bring only the hard data before migrating to the scale, right? I mean, before moving the applications back to the scale. I mean, you can still do that. Right? So there are many ways to. One of the ways to run a policy to check whether the files are migrated or not. If the files are migrated, it's like a kind of a cache to.
What about if you've got dependent file servers?
Dependent files?
Yeah.
They are not supported today. I'll talk about them later. So if you have dependent file sets at the home cluster, if they are doing migration, they are pulled as a directory.
Don't hit in the bottom corner.
Okay, let's talk about real stuff that you encounter every day. I mean, I think, right? Okay. So first thing is the replication performance, right? If you are doing AFMDR, like want to do tuning so that you want to see the better replication performance. The first thing, obviously, one is the number of flush threads that AFM uses. As the default is 4, and if we increase them to, right, I mean, it's a maximum 128. So the more the number of flush threads, the more the operations that AFM tries to use. I mean, it flushes on those threads, right? I mean, we have multiple writes on the multiple files, and they'll try to flush them actually. The multiple flush threads. And so the increasing the asynchronous delay, right? I mean, by default it is 15 seconds. That means you try to write to a file. So what do you say? Like if you start generating the large files, right? I mean, so recently we had observed at one of the customer site actually. So what happens is AFM within the application keeps writing big files, right? I mean, they arrive at AFM the gateway node. The AFM queues at the gateway node, and within the 15 seconds, right? I mean, it tries to flush the write, but there are again the writes are pending in the writes keep coming, right? And so what happens is there is a prefetch mechanism in GPFS where, right, in from scale basically, right? What happens is when you start reading a file sequentially, the GPFS does a read ahead or a prefetch, right? That means the thread which is replicating the data to the remote side, it does not have to wait for the read to come from the NSD server, right? When you do the read ahead. So when you do, like if the same file is getting replicated on multiple threads randomly at random offsets, that breaks the GPFS read ahead. It will not do the prefetch. And And if you replicate a single file on a single thread, right, and that you have multiple large files and multiple large threads, multiple threads basically, right? So you'll get a better throughput, and you have read-ahead performance, and also you have a replication performance. Right? So you could tune based upon your workload. You can set asynchronous delay and the write merge length. The write merge length basically is undocumented option. What you do is, so by default it is 1 GB, right? So if the writes are coming from the application, they split the writes across the multiple messages and multiple chunks, and it tries to execute on the multiple threads. But if you want to write on a single thread, and if you set to the, like if you have a 100 GB files that you often generate, and you set that to the value so that it will coalesce all the writes on the file, and it tries to execute as a single operation. Right, like that you have multiple threads executing multiple big files, and you get a better performance. So
that's writing to cache when you're reading from the cache.
It's
so
writing from
write merge length to enable read ahead. Yeah. So it's writing to the cache, and yet you're reading from the cache. So it's writing from the
cache and writing to the remote side. The
cache of the the remote side.
Cache is local, and the home is the remote one.
Remote, yeah.
In AFM caching.
So this is about reading data out of the cache.
Yeah,
correct.
Right. Even though the parameter is labeled right.
Yeah, right.
Really confusing.
Yeah. So network tuning, it's documented in Knowledge Center how to do the network tuning for AFM. There was some TCP tuning. If we do that. And also limit the number of parallel recoveries. Like some users have like 100, 200 file sets per gateway node. And every instance, if the gateway node goes down, it tries to run recoveries for all the file sets based upon the access. Right? If you try to access the file, they will result in failure because the AFM recovery is an expensive operation. It creates a snapshot, runs a policy scan, and also it results in a home directory scan. Like it has to go over NFS or remote question mode to read, to find out basically deleted and renamed files. Right. So.
Yeah, I have a question. Is there any scenario when a problem with AFM could, I don't know, stop operation at cache side? So if anything goes wrong with AFM, I can somehow be stuck on the cache that I cannot even write on my local GPFS cache.
Not really. So anything that affects on gateway node, it will not impact the cache, but the only mode is independent writer mode because of the synchronous nature. Because until the recovery runs, the synchronous operations cannot go to the remote side, so they get blocked. But because we are trying to fix that with asynchronous revalidation, I'll talk about that. But in the DR, single writer mode, local updates, read only, no. Anything that is a problem with the network or the gateway node, it will not impact anything. So if you have a network issue, it will service the local copied data. It will not revalidate. So, yes.
So this question as well. You said that having lots of caches on a single gateway node risks having do a lot of recoveries if that gateway node goes down. But would you say it's better than to have fewer AFM caches but with more content per each?
Yes, of course, yes.
Okay.
You could do that actually. There are some users that create for multiple. I see in some cases where people create one file set for each customer and with a different set of quotas, and So that means we have more number of files. So I mean, more number of file sets, and in case of failure, it runs tries to run recoveries parallelly. So imagine creating a 200 snapshots at the same time and running a policy scan and all of them. It will overload the system. So that's why you can limit the number of parallel recoveries that AFM runs.
But on the other hand, I mean, if you have really huge file sets, running a single recovery on that will take a long time.
Yeah, it takes a long time, and we have. I mean, I will talk about that later. I mean, it takes a long time. Yes. Of course.
No, I think your question was like, is it better to have fewer file sets but larger ones than to have a lot of file sets that are smaller one? That I think you was asking.
Yeah, so it all depends. I mean, we'd say like the general rule is like we don't want to create more than say 100 to 200 million files per file set. Right? So maybe you can go with that recommendation. I will talk about the recommendations later. But generally, it all depends upon the use case. I mean, if you have enough gateway nodes, you can create a small number of files. That's the recovery and is very quick. Right? And if you don't have gateway nodes, then it is better to create less number of file sets with a large number of data.
Thank you.
So whenever possible, choose MS3 remote cluster mode if you have a reliable network that has a very good performance into more NFS. And AFM hard memory threshold, that is the memory that is used by the AFM for queuing the operations. I mean, when it stores the operations in memory, I mean, you could increase, by default it is 5 gigabytes, and it could increase based upon your workload. So, the application performance, basically, I mean, at least it's only affects independent writer mode because that's where the revalidation happens. Right? You can say you can tune the refresh intervals accordingly. There are 4 refresh intervals for the directories and also files. I mean, it will affect open and lookup intervals, refresh intervals. And there is a config option called AFM Direct IO. With respect to the 2, I mean, what happens is typically you start writing to the data. Yeah, the NFS client caches the data at the AFM gateway node. Right? I mean, it's in the kernel, right? It will flush the buffers asynchronously to the server. Under some circumstances, what happens is when you send a lookup or some synchronous operations, it will try to flush those operations on that. The data, dirty data within the synchronous lookups. Right? That will slow down all the operations of the lookup. Right? So if you use direct IO, then what happens is it will the AFM writes the files immediately using the DIO, so that the client will not use its own cache and it will not try to flush that cache when for the synchronous operation. Say for example, you were doing a revalidation or get attribute of a file, but it has a dirty data in the NFS client cache, so it has to flush that cache to get the latest attributes from the server. So if that is happening in the application path, the applications experience delays. Right? So that's why you use the AFM DIO.
Not only for NFS.
Yeah.
Not MSD.
MSD, yeah, it's usually for NFS. MSD process. So the other thing is, right, frequently the AFM file set like it is stuck, right? It's not replicating, it keeps on staying. So there are different types of things, right? The requeued messages where they appear in the AFM, you see that in the dump, see that typically they get requeued because it cannot replicate the message to other side, like say you don't have space on the remote side, or temporary protocol errors, network errors, they get requeued. And also you have a log conflict between them. So what typically happens is SMB and AFM. So application is if you are writing the data using SMB share, right? They typically acquire exclusive logs or what you call op logs. and AFM requires a read-only lock to flush the data to the other side. So they get conflict, right? Saying that it will not get it cannot get the lock because the assembly client is already holding the lock on the flag. So if that is the case, then the message gets requeued because it's unable to get the file lock to further replication. And once it gets the file lock, so the messages will get, because until then if it has a dependent messages, all the queue will be accumulating. It's not going forward. Right? So until then, what happens is until the assembly client releases the lock, cannot replicate those messages. You could check for it. Maybe you could try increasing the asynchronous delay to make sure that AFM will not replicate those files before, until the assembly client releases the lock. Oh, sorry. So rename operations sometimes you get requeued, and because they are unable to replicate, and they get requeued, and it's most likely a bug in pre-5.0 release because there are some issues handling the renames, like actually circular independent renames, right? Like AFM is unable to figure it out. Like if you move files around, like if you move a file directory 1 to directory 2, and you create a new file in the same place, right? It's a circular dependency. You have to exactly AFM has to replicate in the same manner because it has to create a temporary file and to do that actually. So that was not handled in 4.0. Pre-5.0, but it's handled now.
So would that be more likely to happen if you have long asynchronous delay then? Or is that doesn't affect it?
No, so this will happen only in the recovery process where, say for example, what happens is if it is continuously replicating, so there won't be any problem. But when the queue is dropped or the gateway node is rebooted, right, because of some problem, then trying to recover, AFM runs a recovery process. The recovery is unable to figure out this circular dependencies actually. It doesn't know how to play in that mode. But it is a very rare case where you rename the same file and change the file name between the directories and you create the same name with the same file.
Creating backup files by moving the old file and creating a new one is a fairly standard procedure.
No, yeah, it's a standard procedure, I agree, but there are, AFM can...
Yeah, I'm not arguing with you, I'm just saying that renaming your file to a backup file and then creating a new one, or copying it and then creating a new one. Nothing to say.
Yeah.
But that's only an issue if the gateway is down, right?
Yeah, right.
In a normal situation, you know, it's like a perfect storm.
So if AFM recovery and resync keeps failing, you could use failover, resync, or change secondary commands based upon your need. If they keep failing, it's most likely a bug. But until for a workaround, you could use those commands based upon the mode you're using. And if the things that rate of incoming changes are more than AFM can replicate, then there is a throttling mechanism in AFM. You can throttle the incoming request. You can set say that how much time you could slow down the applications. It may not be suitable for all the workloads. Some users may say, okay, that's fine, but it's okay not to replicate, but replicate slowly, but rather than slowing down the application. It all depends upon the workload. Okay. So this is like based upon right. The number of what do you say? Looking at the heuristic data like problems, PMR. These are general recommendations where follow them. AFM works without any problem. Right. So Yeah, I mean, the first two ones are not hard limits, but if we have that, right, because it will run in case of failures, right? I mean, you have a better handling of recovery, right? Because you spend less time in the scanning and recovering the operations. So usually we say have to dedicated gateway node roles. That means you should not mix with any other like protocols. You don't want to mix gateway nodes with the protocol node designated. Both will compete for the resources. So I mean, it's always preferred to have it also. So number of file sets for the gateway node, there is also limit as much as possible to make number of recoveries that they run during the failure, minimum. Yeah.
You've got no control over which file set goes to which gateway node, though, have you?
Yeah, we don't have. No, I will talk about that later. No.
Okay.
Yeah, we have a slide actually talking about it.
Because that might be mad.
Yeah.
And the other thing is, if your gateway node goes down, and then they fail over to other gateway nodes, and then you bring it back up again, they all fail back.
Yeah, right.
It'd be quite nice to be able to say, don't fail back, we're quite happy, you know, or we could fail back later, because it's just more disruptive for the users.
Or fail back this file set, and this file set because they're quiet, and leave the active busy ones where they are because I don't want them moving.
Or let's do it in the middle of the night. Yeah, it would be really nice.
Yeah, I mean, failback actually.
Well, fail back into recovery operation.
Well, if you wanted to move it back to another gateway, fail back.
Well, you need to fail back to your load, don't you?
Because it was hot, yeah. But it was live, so it was already running. It's not going to do capture, in theory, but it'll do a full recovery.
So the failback is not, it won't run recovery because it does a gateway node queue transfer. Like means from the old gateway node, it transfers the in-memory queues to the new gateway. It's not, if it is already built to the queues, right? It is already, so the gateway node died and the new gateway node took over and it already built the queue and started replicating. Whenever the new gateway node joins back, the old gateway node went down. It transfers the queues to the old node. It's very quick. I mean, so applications are not impacted by it.
Is that a new feature? Because it doesn't seem to work properly involved.
No, it's been there from 4.2.
I've not seen it working.
Maybe, I mean, if it's not working.
It works when it feels like it, should I say. I have seen it working once or twice, but usually where the gateway node comes back and they all recover back, it doesn't seem to want to transfer the queues.
Maybe, see, it will transfer the queue only if the other gateway node finishes the recovery.
Right.
Yes.
Yeah. Otherwise, it will start leaving. So maybe that is the reason.
Right. Okay. So it's.
So keep it down longer time, right? Keep the other guy down until it's finished with the job of recovery.
Unfortunately, when AFM reboots your node in the middle and brings it straight back up, that's the worst case scenario.
I'm just saying.
Well,
there is a line of code in AFM to
I
reboot your
just
gateway.
turned UPFS off so it doesn't come up on a reboot because it's less, just when you put AFM running, I'd rather be in control of when I bring gateways back. So I just don't let it come back.
Cycling, rebooting each other, so it fails over, the next one reboots, and it fails back, and it just, you get stuck in a loop of them. Very good.
Yeah, I mean, so, I mean, there is an issue with Dcache, because AFM directly uses Dcache, and I mean, basically VFS layer, right? I mean, there is an issue, there is a race condition. We fixed it in 5.1, so you could request probably the efix and okay, so you could use auto-pen tracking from like DR side, like you can use even in SW mode and IW mode. You could do, I'm not in IW, it is in SW mode and DR. You could use any other tool like rsync to copy the data, but the AFM will know that the data is already copied. It does its own checksums and it will not try to copy the data back when you enable the replication. Independent writer mode, unless you need it, I mean, because we know in some of the configurations, people, I mean, users actually use it even though it's not needed. Right? We have from the previous experience. It has many problems. I mean, many problems with the revalidation, basically. Right? So we're trying to address that. I'll let you know. But, so even for the migration, never use the independent writer mode unless you truly require it. Like you're modifying the data at both sides. So, and for in the migration case, and you're doing a background prefixes, and make sure that you limit the number of files. I mean, we see people are, users generally they input at a time like 50 million files, and because AFM tries to queue everything in memory, it dies because it doesn't have enough memory for it. Right? We recommend 1 million at a time. We can split, and also I'll talk about the feature that is coming up in next slides. Okay. So those are the general recommendations. Okay. So these are the intended things. I mean, it's not a committed list in this forum. I'm just telling you that. So that's why I try to describe all the problems that we have today, and the scalability issues basically, and things. So today, like the recovery and tracing, where they today, like we'll wait for the recovery and tracing to complete where the application to go back to the DR site. That's not the case. In moving forward, it all happens on demand, right? I mean, it will make sure that it's the applications are not impacted, right? I mean, it all happens on demand. So improve the independent writer mode, like with asynchronous revalidation. So we will not revalidate in the application, right? All does asynchronously, so that the independent writer mode also works similar to the single writer mode, and we have good performance in that. Still, it will fetch the new files and the data being modified. And allow the users to choose file set to gateway node mapping. So when you are creating a file set, you set. These are intended list. I am not committing anything. They will come, but I will not commit any release. Right? You can say, okay, when you are creating the file set, you can say, okay, this is the gateway node for this file set. Use it, right? And you can do the proper load balance. And also the AFM, right, recovery and tracing takes a lot of storage space while it is running, because it generates a lot of files during the recovery, right? Which is like some of the systems with less than 10 GB total systems. Disk space. They have a local file system, and they have like more than 100 million files. It's running out of space, and it's not starting the recovery because it needs more space for it. We try to minimize or completely remove that storage requirement. Yeah.
So then the performance of the local storage of the AFM gateway affects the speed of which the recovery will.
Yeah. So what happens is AFM uses local file system storage for storing the recovery operation. It does a scan, and it does a home read dir, and it compares those operations and generates the list file. So that means you need to have enough space on the local file system to complete the recovery.
Yeah, but I mean the actual performance of the local file system and also the performance of the recovery operation.
Yeah, right. Actually, look, when you say local performance, usually HP4, HP3.
Do we have to go with SAS drives or SSDs or something more specific, or normal SAS drives?
Yeah, that's it's not really a hard requirement for it. You can go with any, because it's a single file and you generate. It's not too. It's the most of the time spending recovery is doing a read dir over the NFS. So if you have 1 million directories, 30 directories to find renamed and deleted files, it has to do read dir and 1 million directories over the NFS to get the data. And that's where the problem. We have seen in some cases recovery running for 10 days with high latency network with more than, right? Because they have more than 10 million directories dirty. MFS is, I mean, AFM is reading directory by directory, 10 million directories one by one. It is listing the content, comparing them. Obviously, it takes a lot of time, and we want to avoid that, right? So, sorry, I mean, sorry. Yeah.
You just got like 2 minutes.
Okay, so that's
Sorry, another question. Is there a possibility, or there will be the possibility, to know that everything up to a certain time of day has been transferred to home? Because I mean, when you have AFM running, you don't know what has been transferred, and if you need to do some operation at the home side, I mean, like archiving or this kind of stuff, you want to know that everything has been transferred because maybe it's
So one way is to you can create a peer snapshot. Like we are in a single writer mode, you create mmp snap command, you see that, and when you create it, so until when that same snapshot is created at other end, that means within that snapshot everything is in sync. If you create snapshot now, based upon the snapshot time, you know that until that time the data is in sync between the cache and home. Right? That is the one way.
With single writer.
Yeah, single writer DR. Independent writer it doesn't support. Because the multiple sites will be writing, so snapshots are supported. And also, there is an in-memory flag. I mean, if you use a dump AFM command, MMFS ADM dump AFM, it shows what is the last synchronous sync time. It's an approximate. It's an approximate, but it doesn't give guarantee like a peer snapshot. Peer snapshot, you know that the data is there. So, like we have externalized some of the like we have internal configuration parameters. I'm going to externalize them so that these are undocumented. Put it on the knowledge center so that, right? And also small performance improvements where you have like the AFM, right? So it all depends upon the write buffer size that you create. Like if you create a 1 GB file with 1 GB buffer size, so there is only one RPC sent to the gateway node. And if you create a say 1 MB buffer size with 1 GB file, there are 1024 RPCs are sent to the gateway node. It all slows down the performance. We want to improve that performance actually. Okay, it's almost done. Sorry. And the last one is dependent file support. Dependent file support. We are looking for it. Like AFM won't replicate them today. So it's supporting more than 1 billion files per file set. Right? That's fine. I mean, there is no hard limit. It still works today, but the thing is, in the failure cases, scanning them recovery takes a lot of time. And also the migration AFM preface. People users were asking for directory level support. Hey, you'll give you files at root. You prefetch everything. Automatically it does the scanning and do that, right? So providing the what files failed and data movement statistics and the other things that you can do. That's all I have. Any questions? Yeah, sure.
You said at the beginning that the writing, reading all had to use the slow path to read data to go back to the cache. We've noticed that we've got a lot of, when we write to the writing to the cache, i.e. single writer back to target, writing to the cache, if you don't have the right block size, it can be very slow, slower than the other underlying file system would normally be. Is that due to the use of the fast path and slow path?
Yeah,
I've managed to tune it out at the moment by I've used testing using DD and changed the block size and improved the right numbers. Much more than a non-AFM file set. Is there any way to get the caching buffering that working?
We are working on it actually. So today, when you write to the file, the RPC is sent in application path to the gateway node. So
yeah.
application gets the control back. I mean, if you do the write is API, right? It returns back only after sending an RPC to the gateway. But instead of that, you do it in the background, the pop-up must start. That means, like, it's all right, not in the application part.
Yeah, I mean, it's making the writing to a cache about 100 times slower when the non-AFM files set on the same
That
task.
flow is not there.
I mean, this is a bad example. I suspect, but
Okay.
yeah.
Okay. Yeah, I know. I mean, we know that there is from 1.2x to 3x or 4x, but not 100 times is. Okay. I mean, it all depends on the workload thing.
Yeah, I suspect it is. I mean, this was just a simple DB tag. I managed to tune it out. Well, what's going on here? I mean, it's the fast passes and the slow pass.
We need to kind of top the sessions around, so it's a really quick question.
No, just for the list of announcements, besides getting the undocumented parameters documented them, it's also some better understanding of the tools you can use for debugging it. And in our case, this coalescing the parameter was very important for the performances.
Okay.
But it's okay, it was undocumented, but even there it was not easy to understand.
Oh yeah, I understand. Yeah. We'll update it with the examples in the documentation.
Okay.
So if you have to scale on Z, because I'm not American, we'll see.
Thank you.
Scale on Z to the network flows in right over there. John, you're in stuff on that. And then here's just the
Suppose that's that.
Yeah, I wanted to learn more about that. But I didn't understand about the replication case and cloud object storage. Maybe lunchtime you can explain to me? Okay, thank you. Because I was wondering about the stub and all that. Okay, thanks a lot. Yeah, I'm going to go visit my little girl today. Yeah. I will go have dinner. It's a long way to go. You know? When she was
Do you have your dongles? We don't have dongles for that.
Which hotel are you? So,
We've got HDMI, but it's HDMI, yeah. You got mine there?
what time are you doing?
Oh, after the session, you know, because she has she's in an app and it's
I'm gonna get it. Yeah, I'm gonna take a sweater. Yeah. Yes, I am.
There you go.
That wasn't you. Oh, okay.
So how many gateways? At the moment, one, but we are destroying.
I'm sorry.
I'm fixing it by dropping them immediately. I know did
I just assumed yeah.
Brilliant, thank you.
So I guess we can get started. All right, so yeah, my name is Matthias Dietz. I'm working in the research and development team in Kelsa, Germany. So I'm part of the spectrum scale development, and my current role is that I'm the RAS architect for spectrum scale, taking care of things like monitoring, resiliency, availability, and also call homes and health monitoring. So those in my responsibility. So today I have 3 topics. So we have one slot for 3 things. One is health monitoring, another one is performance monitoring, and the third one is call home or proactive service. So before we start, I would like to see who is most interested in which topic. So I mean, I have a lot of slides and I have a lot to show, and I have much more than I can talk about in 1 hour. So I really would see some preference here. So who wants to hear most about system health or health monitoring? Right? And performance monitoring? Okay. And what about call home? All right. All right. So, okay, then I will probably put more focus on performance monitoring and system health, less on call home, but I will talk about all 3 topics. So let's start with health monitoring. So I'm not sure how many here in the room already used Health, which is our command to query the health state of the cluster. So this page here describes really how that works, how our health monitoring architecture looks like. So in fact, we have introduced health monitoring with spectrum scale 4.2.1, and when you run spectrum scale on Linux or AIX, you will automatically have this new health monitoring daemon running on each of your nodes and monitoring the system. And this health monitoring daemon is basically the backend for the Health command. When you use Health node show, you can query the node state, but I will come to that later. So we decided to have this daemon running on each individual node to have some decentralized monitoring. So each node is just responsible, or each daemon is responsible for the local node. We try to avoid any network communication between the nodes. We try to avoid any dependencies to other nodes, so that the monitoring is really responsible for the local node only, and to avoid any scalability issues or issues when network also is broken. We don't want to have impact on the monitoring. So, meanwhile, we have about 27 components covered by the health, and we are extending the health monitoring from release to release, adding new components, adding new features, adding new events and monitors to it. As you can see here in 5.0, we added, for example, file audit log as a new component because that was a new feature in 5.0. In 4.2.3, we had several others like AFM or the message queue or thresholding. And as part of each component, we have a list of defined events. So what things we are monitoring and the outcome of that monitoring. So meanwhile, we have over 650 events and more than 170 different checks in the system, which really verify or try to detect certain problems. Here are some examples, like GPFS. When the daemon goes down, you will get a GPFS down event. Or if we have some deadlocks hanging, you will get a long data as found event. Or if you lost your quorum, then you will get a quorum loss event. So how that works? So health monitoring, as I mentioned, is based on events, and these events can trigger state changes. And in our system, a node or a component is either healthy, degraded, or failed. And depending on what events the monitoring has raised, the state will change. So for example, if the monitoring finds out that your GPFS is up and running, your file system is up and running, then there will be a good event. There will be GPFS is up and the state will be healthy. And using the health command, you would see that state. And you can quickly identify that your system doesn't have a problem. But when your GPFS daemon crashes, then there will be another event like GPFS down, and that is a failed event, and that will change your state to fail. Right? And then by looking with health, you will see, okay, the state of my GPFS is failed, and the reason for that failed state is because the GPFS daemon is down. So we have different sources on how we detect problems and how we raise events. The one in the middle is the monitor. That's really some code which is actively polling different conditions, right? It's using internal APIs as well as normal commands to poll certain states and find out if there's a problem. In addition to that polling, we also have register to internal callbacks and to all kinds of notifications to get informed from individual components if there is a problem, right? And the third thing is command. So we also have a possibility to raise events from a command, and sometimes we do that when a problem occurs during the user command execution, right, which is changing the state of the component. And yeah, as you might know, I mean, we would like to avoid polling where we can. So it's always better to rely on notifications because it saves resources and it's instant and you have a much quicker result. But in many cases, we cannot rely on notifications and have to do some polling in addition. And this polling is done on a fixed interval. And here you can see we have different intervals for different services. For CES, so the health monitoring is also used for the CES protocol monitoring. And in case of CES protocol monitoring, the health monitoring will also take care for the failover protocols. And for this reason, the interval needs to be quite low to have a quick failover time and do not have an impact on the, or a larger impact on the connected protocol clients. For all other services, the intervals are a bit higher. And for some services, like the ESS firmware checks, we even do checks only once a day, because that's kind of heavyweight and we don't expect the firmware to change very often. So, so we just do it once a day.
But it's worth doing it on boat or something stupid.
Yeah. But this is important to understand because this also means if you raise an event, for example, that your firmware is outdated and you need to update your firmware, it can happen that once you did update the firmware, you still see the event because this interval did not start yet and the event did not disappear. So in this case, we have a -- refresh option. It's undocumented. That's why I'm here.
You just documented it.
Where you can trigger it, instantly.
Yeah, I'm looking for that. So do you do MMX, then the max?
Health, node show, -- refresh. or if you just want to refresh a particular component, Health, node show, GPFS, minus refresh, or what the component is, right? So in the past, we had some customers complaining about resource usage of the health monitoring, especially customers running HPC workloads, running MPI workloads, and having large clusters saw some impact on their jobs caused by the health monitoring. One reason we identified was our GSKit library was not very efficient, and Health was, or the health monitoring was doing some checks which required constant authentication to do some operations, and that caused the GSKit library to do some initialization steps every 30 seconds, and that was just causing CPU. So meanwhile, we did two things. We improved GSKit a lot, but also we took that out of the health monitoring. So we think meanwhile there is no large impact anymore. If you still believe or see some impact of the health monitoring, we also provide a way to change the health monitoring frequency. So you could set that to low, and if you set it to low, it means the intervals will be 10 times larger, right? Instead of 30 seconds, you would have 300 seconds interval, which also means, right, it will take longer until we detect a failure, and it will take longer until problems go away if you fix them. All right, so I mentioned that we have this local monitoring on each node, and the Health node show command shows that state of each server. But for many people, it's really important to get a cluster-wide view of things, right? To have a quick and easy entry point to find out, is my cluster healthy? You don't want to log into each node individually and look at 100 nodes or so. For that, we introduced a cluster state consolidation, which is basically just a summary of the states and events of all the individual nodes. The important thing to know for this cluster state consolidation is that it really is just a consolidation. It gets all its info from the individual nodes. So individual nodes, as I mentioned, do local monitoring. They always have a consistent state. They always, have the right state. And on the cluster level, we forward the events from all individual nodes to a single CSM node in our terms, which is building up this consolidated view. And this forwarding is, I would say, eventually consistent, right? We don't think it's super critical to be in sync all the time, right? For this reason, we send out events asynchronously, right? And that means the cluster state is very good to get a quick overview of the cluster, but it might not be 100% accurate. So it might be that from one node the events are delayed, or you might have some network errors, so you would not see the events from a particular node, even though the node is maybe healthy. And what I'm trying to say is the cluster consolidation is really good to get the first impression, but if you want to have a definitive answer of the state of the server, you should use node show command on the local node to really see what's going on. And here I have an example output of the cluster state command, and also the recommendation how you would start looking at your cluster state. So you would first start using Health cluster show. In this case, you see a list of the components, and you see the different states, right? In this case, you see one node which is degraded, the four other nodes are healthy, and you see one node has problems with CES, and the other CES node is healthy. So in this case, the next step would be, how do I find out which node has the CES problem, right? So you would execute one more command, mmhealth cluster show CES, and then it would already show you the detail, right? So these are the CES nodes, and the second CES node is failed, and the reason for that is network IPs down, or in fact NFSD down. So that's a root cause. Now, as I mentioned before, the cluster consolidation is just a combined view from all the nodes. To be absolutely sure and to get all the details, next would be to jump on the node itself, and now that you know it's CH42, go to that node using the mmhealth node show command, specifying the CH42 node, or you can also log in via SSH and run it locally. And then you see much more details about that node. So first of all, you see 9 minutes ago, the CES state failed because the NFS down event appeared. So what does NFS down mean? Actually, you can use the mmhealth event show command to get an explanation of the event. What does it mean? How can you fix it? What state is it? And what reason it has. So sometimes these events are kind of light, it's a description, and we are working on improving the event description and especially the user action from release to release to really make sure it's helpful for customers to solve a problem without contacting IBM, right? Because I think you and we are happy if you don't need to open a PMR for a particular problem. So you can also look in the info center, Spectrum Scale info center, for a list of all known events and user actions and descriptions and so on. So that's about the mmhealth node show command and how you would debug a problem which happened right now. But in addition, we also track a history of events, right? So we offer you an event log with the mmhealth node event log command. You can see what happened over the last day or over the last week, and really, understand why your system might have a problem or since when. Another thing, and I mentioned that before, just briefly, is in addition to the events which cause a failed state or a degraded state, we also have tips. And tips are basically events where we detect some misconfiguration, but it's not a hard problem. We let you decide if you think it's worth fixing in your environment or not, right? One example here is a page pool small. So we would detect if the page pool configuration is still at the default value of 1 gigabyte. And some customers run with that default value because they just don't know that they have to adjust the page pool. So in this case, meanwhile, we raise a tip for that and notifying the customer that you might want to overthink if, the page pool size is really good and you might want to configure a larger page pool. But if you don't, so if you really know what you are doing and you think, my page pool is absolutely fine, I don't care, you can just hide this tip. You can just say mmhealth event hide with a GPFS page pool small name, and then the tip will disappear, right? So, and we are going to expand from release to release what configuration checks we added and what the so-called best practice violations we check and verify, and will release more and more tips over the next releases, which can be hidden by you if you don't like them, or you can optimize the system by following them. Another thing is performance thresholds. That's also part of Health command. I will go through that in more detail when we talk about performance monitoring. And finally, you can also use the Health command in your own tools. So it has a parsable output, so you can use it for scripting. You can also use the REST API to get the health state if you don't want to use the parsable output. Yeah.
One thing that'd be really nice if you had a --JSON.
That is a REST API.
I know, I don't want to spin up the web service. I just want human help and I want the JSON. This is okay.
I know.
JSON would be nicer.
Yeah, maybe easy script to convert to GPFS -y.
That's what I'm going to do. My own script will have to convert this into basically a dictionary format anyway. Okay. But if it was JSON already, it would save me this operation.
Okay. All right. So a few things we did in 5.0, and I mentioned a few of them yesterday already. So we added a check to look for free space on var MFS. And if we run out of space on that file system, we will raise degrade event if I think less than 500 megabytes are free. And we will raise an error event if less than 100 megabytes are free. And that will then pop up in Health, and the state of the component, I think it's part of the GPFS component, that will change to degraded or to tail, depending on the switch rate. And this means you know that you have to do something quickly to resolve the problem. Same with the GPFS unresponsive. When the daemon is unresponsive, we raise a new event, and that will change the GPFS state to degraded and will also appear in Health. I already talked about the Kafka file audit logging monitor, which has been added, and TCT had some improvements. I talked about the jitter reduction with the interval, as well as GSKit improvement. So one important thing to notice here is ARX. So the file system monitoring, the health monitoring is running on ARX as well, but with reduced functionality. So it basically just monitors the GPFS daemon, and with 5.0 it started to monitor the file system. All other components are not available on ARX. Is somebody in the room who is using ARX? Oh, that's good.
I'll let them hear you say that.
Okay, so another feature, I mentioned it yesterday, we introduced an option to call a script call out every time an event happens on the system. So you need to place that script to var MFS etc, and it needs to be called events callback. And then every time an event happens, the script will be called with events as a parameter. It will get a version, timestamp, event name, component, identifier, severity. So it will get all the bloody details of an event as parameter, and then you can start, doing something with it. You can grab for particular events and do something with it. You can forward the events to your own monitoring tool or you name it. One important thing is this call-out script is really supposed to be very lightweight. You shouldn't do a restripe operation, or in fact, you shouldn't do any command directly in that script to also avoid deadlocks and so. Right? I wouldn't expect those, but to be on the safe side, don't do it, and you shouldn't do any heavyweight commands in that script. If you really want to do heavyweight things, you should think about how to offload that in a different thread. And in fact, the script will get killed after 30 seconds. So if your script runs more than 30 seconds, it will get killed. So don't be surprised. All right, that's all about health monitoring. Any questions to that? Everybody happy?
not directly on the Health itself, but since you mentioned the event call, like what we have started working with is especially node expel overrides in a situation where you have multiple fabrics and you have a link failure on one fabric, but the fabric on which the GPFS plus the node is defined is actually still healthy. Your default would be to kill the remote node that's sitting on that other fabric. So we're overwriting that because we want a node failover to the other NSD server. Right? We have seen that this is relatively unreliable, so our event actually calls shutdown on another node. Is that too heavy, or should we go and fix why it isn't working with the standard expel? So we've tried everything, right? We've tried failovers manually. We tried just returning one and let the expel logic do its work. But in some cases, it just gets stuck and never triggers the failover. So that may be just a bug that needs to be fixed. So if I'm in a healthy situation on the main fabric, I run an shutdown on the node that I want to force failover. Is that okay, or is that a risk?
So but you don't mean within that call out. You really mean with
yeah, within the expel node exit, but it could be there as well because we weren't sure which way to go.
So usually in the user exit, I mean that's different from the health part. But in the user exit from GPFS, we also recommend to not use commands to avoid that loss.
Yeah,
that's. I'm not sure if shutdown would be safe. I have to double check. Maybe we can take that offline.
Sure, absolutely.
Yeah, for me, you said the cluster view is not definitive. So if I will be rewriting our monitoring, and so if I want to use Health, if I use the node show and give it -n basically all NSD nodes or class, whatever, then that will give me definitive.
Yeah, definitely.
State of
definitely, but obviously it has to go out to each node, right? And if you have network problems, it might not be able to get to each node. The cluster state, I think.
How are you going out to those other nodes? It's using SSH internally to get the answer back. So
yeah, sure.
Probably do exactly what you're about to do.
Yeah, I'm just mentioning that point with the cluster state because in most cases it's really accurate, right? But there are some edge cases where you can, when the events cannot be forwarded to that cluster state manager, so then you might lose events. And instead of having a discussion with customers if that is a PMR and for something went wrong, I try really to make clear that this is by intent, or not by intent, but the concept how that works is not that it's 100% reliable. All right, performance monitoring. How many here in the room are already using performance monitoring in Spectrum Scale? I mean, our performance monitoring tools. Okay. Okay. So yeah, as I mentioned, Spectrum Scale comes with a performance monitoring solution. We call that CMON, that component internally. And one does, it collects performance data from all cluster nodes and is separated into sensors and collectors and has a scalable, extensible architecture. So we believe we can scale up to the size of a full-blown GPFS cluster. I mean, our maximum cluster size is 16,000 nodes in theory. All this data is stored in a time series database, and there's some aggregation, and we have multiple interfaces how we can get to the data. And I will now go in all the details a bit and explain it a bit more. So let's start with a system overview here. So here in this example, you see a 4-node cluster, or it might even be a 6-node cluster. Let's say a 4-node cluster. And on each of these nodes, you have the CMON sensors running. CMON sensors is when you are logged into the system, you see a service called PM sensors, which you can start with systemctl, right? And this CMON or PM sensors has several individual sensors which collect different things. So, for example, we have a GPFS disk sensor which is collecting GPFS disk information. We have a GPFS file system sensor which is collecting information about file systems. We have a CPU sensor which is collecting CPU information from Linux and so on. So I come to the detailed list of sensors later. So how it works is each node has these sensors running. These sensors collect the data and push that data over the IPFix protocol to so-called collectors. So in this picture, you see the collector is some other component running somewhere. We recommend that the collector runs on your cluster nodes as well. So if you have a 4-node cluster, you would choose one of these nodes to be the collector node. Right? It's again a systemd service, PM collectors, which you would need to start, and then the sensors will send the data to that collector. And the collector is, in fact, the time series database, which is storing all the sensor data, and then can be used from, for example, the spectrum scale GUI or other means to query the data. So I mentioned that we have some aggregation, and here's an example how that works, right? So the collector has different domains and different periods, and after some time, when you get data, let's say in a 1-second granularity, and depending on your configuration, the collector can aggregate this 1-second granularity later into a 30 seconds granularity. And after some more time, let's say after some days or a week, it will aggregate the 30 seconds granularity into a 50 minutes granularity. And then after some months, it will change it to hours. And eventually it will delete the data if you have configured it. So by default, we come with a predefined set of domains, which we think makes sense for most of our customers. We do not provide commands for changing that. It's just a plain configuration file on the system. So if you want to change the domains, you have to go into that file and update the file. So, and this is how it looks like. When you query the data later on, you will just see a change in granularity, right? So 1 second for data which is maybe up to 24 hours old, and 1 minute granularity or so for data which is older than a day. Another feature of CMON and the collectors is federation. I had on the first picture that you can have multiple collectors. And for scalability, it's really recommended to have multiple collectors if you have large clusters, right? So depending on your systems and on your hardware, we say about up to 100 nodes could send data to one collector. So if you have a 300 node cluster, you should think about having 3 collectors.
Sorry, with which resolution of the data from the sensors is this matrix?
Yeah, that also plays a role. I would say this is the default setup where the GPFS metrics are with 10-second resolution, and the Linux metrics are 1-second resolution. But be careful. It really depends on your hardware, right? So especially from a CPU and from a network usage, it depends on the hardware. And in addition to that, you always need to think about the memory consumption, because CMON has this time series database in memory. And if you now have a large cluster with a large number of CMON sensors enabled with high granularity,
then the memory consumption can be multiple gigabytes, right? So you really need to plan and reserve for that.
Because we have, actually we are using a collector on a virtual machine for multiple clusters, and we see pretty bad performances. So we are looking what's the issue.
So you see bad performance when doing a query, or
basically from the Grafana bridge.
Yeah,
so trying also to run like multiple telnet queries to the collector, we see very bad performance. So we're looking to understand this better.
Okay.
For the federation, is it possible to run collectors on all nodes? So each node is its own collector. Now, accepting that you might lose data and that node is down, right? But you're not concerned about that. You'd have the agent and the collector running on every single node, and then they federate for queries.
I think it would be possible. I'm not sure if it would be good. Because that means, federation, I was starting to explain it for all others. Federation means if you have multiple collectors now, you can talk to one collector and it will give you, it's a big picture. It will give you, when you do a query, it will underneath contact all other collectors to get all the data from all collectors, right? So you all, from a usage perspective, it's transparent to you that you have multiple collectors because you just ask your primary collector for data. Now, if you make each node a collector, then obviously the query might be more expensive because now you have to go out to all nodes to get your data. Right?
Let's say I had a small group, 3, 4, 5, 6 nodes. So I guess that would be quite cheap in terms of collection. Now, 15,000 nodes, absolutely, but. I'm
not sure what benefit it would have. So we never tested that. So some install tips here below. So having more than one collector is not only good for the load, but also if you want to have HA. And we have an option called collector redundancy. So if you set this collector redundancy to 2, it means that each sensor will send the data to 2 collectors, right? So if one collector is down, the other collector still has the data, right? But it also doubles the amount of data. I mean, instead of having let's say 10 gigabyte RAM usage just on a single collector, you now have them both. Right? Sorry. Another important thing is when setting up collectors and CMON itself, make sure to use the GPFS host names. As I mentioned before, we recommend that the collector is running on the GPFS cluster, node. And if it does, then really use that host name. And many people use different host names for the system itself, for GPFS daemon, for GPFS admin network, and we recommend to use the GPFS daemon address or daemon name for setting up the collector. All right, and as I mentioned before, same as with domain configuration, you need to, if you want to change the federation and set up federation, you need to go into this CMON collector config file and update that. So I really need to speed up, I think, because I still have many slides. So here's a list of sensors. It's not a complete list, but it gives you some overview. So we have several sensors related to the basic operating system, like CPU, load, network. For memory. For network, we have things like the network, bytes read, bytes written to the network, and so on. We have netstart. We have InfiniBand specific counters. We have local disk counters from the operating system. And then we have, and these are missing here, the normal GPFS sensors. Oh, they are missing. Except capacity is here as well. So CMON is not only used for having normal, performance-related sensors, but we also have capacity-related sensors, which you can use to see disk usage or file system usage over time. Then we have additional sensors for dedicated components like TCT, file audit logging, AFM, and a bunch of protocol or CES-related sensors for understanding NFS traffic, SMB traffic, CTB logging performance, and things like that. So one common mistake people did is in regards to capacity sensors, that's a cluster-wide information. So you really need to make sure that this runs only once in the cluster. If you start that multiple times in the cluster, it just causes unnecessary load on your cluster. And if your cluster is very large and you have really running MMDF on 100 nodes in parallel, that can even impact your cluster I/O, right? So, and can all kinds of problems. So really make sure that capacity sensors are restricted to a node. Same with quota sensors.
Probably a good idea just to disable the MMDF list by commands for all the sensors, but only actually run on connector or something.
Yeah, but what we are right now working on for the next release is having a singleton concept, which means one node is elected by us who is a primary sensor for collecting this capacity data. But that's not in a version yet. That will probably come out with the next release with 5.01. Right? But for now, everybody has to make sure that it's configured correctly.
Yeah, we use whoever the current cluster manager is does it for us.
Okay, you did that. Okay, in our case, we use we choose one of the collector nodes to be the primary collector node, and on this collector node would also do this capacity collection. All right. Yeah, here maybe it's getting a bit more complicated here, but here I try to point out which different sensors collect data at which point in the whole GPFS queue. So we have the GPFS VFS sensor, which is really at the very beginning at the VFS layer of Linux. So it just counts VFS operations like how many reads, how many writes, how many deletes, how many opens, and so on. Then we have the GPFS node API, which is collecting things like written bytes, read bytes, and so on. But that is, as you can see in the stack, it's before the page pool. So it will also will show everything which the application has requested GPFS to read or to write, right? That's a node API, and compared now below here we have the GPFS node without API. And that is basically the same metric. It's read, write, and so on, but it's behind the page pool. So every cache hit would not be reported here, but it would be reported above, right? So that's important when you really want to look deeper into the data and use that. You have to understand where it comes from. The GPFS CHMS sensor, that's cache hit miss sensor. So it really gives you some metrics about cache hits.
Assuming it's also getting things like LROC data at that stage.
I don't know out of my head. It could even be that we have a dedicated LROC sensor, but I don't. I have to look it up. And then when it comes to NSD traffic, right? So all these sensors here are on the GPFS client side. So when you do a particular I/O operation on your GPFS client, these counters will go up. But there are a few sensors which are on the GPFS NSD server side, like the GPFS NSD and GPFS PDisk on DSS. They will go up when they get some traffic remotely over other GPFS clients.
Now, to make this picture a bit more complicated, I mean, that's quite easy. If you do some I/O of 3 bytes, then 3 bytes will appear here. If nothing is in the page pool, 3 bytes will appear here. And 3 bytes will eventually appear here. Maybe, yeah, 3 bytes will not be distributed, but maybe here and here, right? So that's quite easy. So everything is the same. But usually you don't have such easy setup. So you might have, for example, on the NSD server, you might have a client as well. And now, depending on how your traffic looks like, the counters are different. So for example, here within the NSD counters, you would only see traffic which comes in through the remote NSD, so the remote client. When you do I/O from the GPFS client running on the NSD server, you would not see that in the NSD traffic because it's not NSD traffic. It is like local I/O, right? So it's sometimes it requires more or a deeper look to really understand the counters and to understand how they are built and where they are get from. All right, so we have 10 minutes left. I would like to skip to call home to at least talk a bit about call home. The slide deck will be available after the call. I have here some examples how to use mmperform query to query the performance data, how to use the spectrum, or screenshot of the spectrum scale GUI, which is nicely showing the performance data and graphs. The Grafana bridge is another component which we offer where you can install an additional package which will then allow you to use Grafana, which is an open source tool, to access the CMON data and display the CMON data in Grafana. And we have these capacity and performance thresholds, which is basically the link between performance data and system health. So you can define thresholds on any metric of any of those sensors I showed you before. And if such a threshold is hit, it will raise an event in system health. And this is highly configurable, so you can set anything using the mmhealth command. mmhealth threshold at CPU idle, for example. So if your CPU idle value goes below 60, right, 60%, then you would get an event here, right? And you can do all kinds of nice things. The CLI is a bit, complex, but for that now in 5.0, the GUI has a nice panel to set thresholds, and that is really, really useful because when you start to set the threshold, you will also see the corresponding data which happened over the last day or so, and that can help you to really find the right level which you want to specify. All right, 10 minutes, 7 minutes for call home. So, who in the room is already using call home for spectrum scale? Nobody. Is anybody using call home for other products?
I tried it, but properly configured.
Yeah.
Yeah, I know.
We do it for Mellanox. Because
So,
they have too many problems.
Yeah. All right.
Does that mean they actually respond when your device calls home? Because
Yeah,
they
we
will be
actually
calling
have to tell-
home, but nobody may be listening.
We actually have to tell them not to. This is just a known firmware update or something. Don't bother us.
Okay.
We sent that to you anyway, but.
Okay, so let me give a quick overview. So Call home spectrum scale is a bit different to other call home implementations on other IBM products, especially when comparing with DS8K or other storage products, because the other hardware or storage products are mainly focusing on opening problem tickets so that support can work on it. In case of Spectrum Scale, it's a software call home, and our primary focus was not to open PMRs and problem tickets. It was to collect the cluster configuration and collect log data so that our support team can more quickly act on that on a support ticket, even before the customer uploaded a full GPFS snap, right? And so for this reason, our call home today has two functions: uploading daily and weekly data collections, and second function was triggering uploads based on events. But it does not, again, not open defects or PMRs. That is something we want to do in the future, but it's not part of the call home. Call home is disabled by default, as you know, so otherwise, I guess you would have enabled it. But now with 5.0, when you use the install toolkit to set up a cluster, it would ask you for the call home setup, and you would have to opt out if you don't want it. One important side note is on ESS systems, there are in fact two call homes. One call home for the hardware part, which is opening PMRs, which I just mentioned. But in addition, you can use, and you should use, the software call home part, which is what I'm about to explain. So my recommendation is really to enable both on the ESS system. So call home today, that's how it looks like. So when you have a cluster, we separate the cluster in so-called call home groups, and each group has a primary call home node, which is responsible for sending the data to IBM through the internet. The data is stored on an IBM support server called EcoRep. This EcoRep server is GDPR ready, which means the data is safe there. It will not go out. Even the development team, starting with GDPR in May 28 or so, 25, even the development team is not allowed to download data from EcoRep on their personal laptops or so to analyze data. So this GDPR system is really a closed system, which is so this EcoRep system is really a closed system, which is GDPR ready, and the data has a retention period and will be deleted and so on. So, and the IBM service team, as well as the development team, accesses the EcoRep server for the call home data and also for any PMR data which you upload as part of the PMR. So I already mentioned that call home collects mainly the configuration, it collects log files, it collects some statistical data. What it collects in detail, you can look in the config files described here. So you can always go in the system, look what commands we execute, and so one important thing to mention, it should be clear, but we do not collect anything from your file system or so, right? We do not collect any customer data which doesn't belong to the GPFS configuration. Our primary goal is really just getting the full configuration to help with problems and find issues. So here's an example list of things we collect, like MM-Diag output, MM-Health outputs, MM-LS cluster to see the cluster configuration. And we collect that all in parsable format so that we can really automate the analysis of that. Here's one more example, MM-LS cluster. And with the next release, we'll also start to collect some of the basic performance data. All right. What's new in 4.2.3? Let's jump over this. Yeah. So one thing to mention is today call home, as I mentioned, is what it is. It just uploads the data, and the data is used by the service team. But we do not have any automatic analysis of the data, not have any proactive failure detection and notifications. And that's our goal. We want to make a proactive service tool out of call home. And this will be achieved by storing all the call home data in an anonymized way in a central database, and then run reports on that database, run queries on the database with simple rules where we can look for known error patterns, known problems. If we see an error pattern with customer A and we are aware of that, we can apply that rule to customer B or to all other customers to find out if they would run into the same problem, and can really proactively detect potential problems. And that's really our goal. So the very first step will be to consolidate the call home data in a database in an anonymized way, run simple reports on it and simple rules on it, and based on the outcome of these rules, get in contact with the individual customers to warn them about critical conditions. Right. The next step then is to run more complex analytics on that data to again detect problems automatically. And we are also working on a back channel. And maybe I can show that here in the picture a bit more. So we are also working, and this is your cluster, that is IBM. We have the data here. We run analytics on that data. We find a problem with your cluster because we know about this problem from other customers. We can, here with the back channel, go bring in this event that there's a problem back to your system and raise that in Health, in the GUI or whatever. Right? That is our goal, to really expand the capabilities of the local system. So we have health monitoring on the local system, but it's limited to the software release you have installed. Right? If you don't do an update to the new release, you will not get new monitoring services and conditions. You will not detect new problems. But with the whole cloud side here on the right, we would be able to add new rules even if you do not update your system, and you would get early informed about problems and issues of your system. So that's really a long-term goal we are working on.
There's a danger there that people will get a tip and it'll say you're running 4238, you should upgrade, and they'll look at that and say most notifications will upgrade. I guess it's quite a risk, because if you do discover a problem with the customer system in this way, chances are the fix is upgrade your cluster.
Yeah, that might be the case. Yeah. So, we have one simple example also. For one of the very first rules would be to warn customers about unsupported versions. So if a customer is still running, let's say 3.5, okay, yeah, then we wouldn't have gone home, but then you would say, yeah, you are running with an unsupported version, right? And we can update this version with, on the fly without having a new release in the field.
I suppose as a provider keeping best to customers, it would be nice to be able to silence specific things like that that's coming through, because we can move it over customers to have that in their face to have problems to deal with.
Exactly. So this must be very configurable and customizable. So we don't want to spam the customer with things he doesn't want to see. So it's really and there will also be a choice if he even wants to have his data used for that. All right, here are a few points why you should enable call home already now, today. So once you get back to your system this evening or tomorrow, please enable call home, right? Right? I mean, so first of all, it improves our service response time. So it can really help to get the service team started quicker with PMR analyzers. It also has nice features for you, like uploading snaps through call home. instead of going through the web interface. And what is important for me is you help us to improve our development and testing, because by looking at your call home data, we understand better how you use our software, how you use the system, right? And you know, we can, if we see 90% of our customers use AFM with I don't know, remote cluster mounts, then we might test this code path much more than if we don't know that information, right? So it's really helpful for us to understand how you use the system and to improve our development as well as our testing.
I was reading the ESS, I was reading the upgrade guide, and is it right that if you need to enable call home, that's a lab services activity? You can't do it yourself?
That's probably for the hardware call home, I think so, yes. For the software call home, I think you can do it yourself. Yeah.
That's true.
All right.
You pretty much at time, and then you move the walls back to the room this afternoon. Sorry.
I think I'm done. So in the slides, you will find 3 slides how to set up call home. So if you are, as I mentioned, back onto your system, look at the slides and enable call home. It's quite easy. Thank you.